I am going to work some examples off of worksheet 13.5. That's the change of base worksheet. But before we do that, it says in the top part, use the calculator to approximate to the nearest thousand. Now, the decimal places have, the way they work, the first decimal place is tenth, then hundredth, then thousandth. Thousandth would be 3 decimal places. But the bottom part says round to the nearest 10,000th. That would be 4 decimal places. Just to make it easier, we're going to round everything to 4 decimal places. So you can change the top instructions if you want to say 4 decimal places. And because we're not very good at rounding to the decimal places, we are going to use our calculator tool. We're going to make our calculator round off for us. And so right here on the calculator, would you push the mode button? Push the mode button right here. Let me see what. Come back, calculator. The mode button right there, and then this second row is what controls the decimal. And so we want to be the first row, we always want to be normal. And then on the second row, we want to, you can set it to however many decimal places you want to. We want to set it on 4 and then push enter if it's not already set like that for you. And so then when you do something like 8 divided by 2, why does it have all those decimal places? Because we just set the calculator to have decimal places, because that's what we're going to need on this worksheet we're about to complete. So, on problem number 1, it says log base 7 of 22, and we are going to evaluate that. Now, when we did our foldable notes the other day, we wrote down the change of base formula. And I've also written the change of base formula over here on the board. The change of base formula says the log of the big number divided by log of the base number. Now, these logs right here are base 10. Because they're base 10, I can use the calculator. So with my calculator, I push, clear that out, log of 22, close parentheses, divided by log of 7, close the parentheses. You will not get the right answer if you do not close the parentheses. You will not get the right answer if you do not close the parentheses. And so, it's rounded off for us, 1.5885. 1.5885. Easy enough? Fairly easy. So, let's go ahead then and skip down to problem number 7. The change of base formula, or the log, is very helpful to solve this kind of problem. Now, when we were doing this kind of problem before, we didn't use the calculator. We changed it to the same base. But can the 62 be put in base 5? No. So without additional techniques, we couldn't solve that. And that's what we're going to learn how to do today. We're going to take the log of both sides. Now, I did not say multiply by the log. I said take the log of both sides. You have to have the log word in front of the number. It is incorrect to write 62 and then a log. Now, by the way, I took log base 10 of both sides. Do you remember if the base is not written, the base is 10? Why would I want to use base 10? So I can solve it with my calculator in just a minute. The power rule says that this number that's a power can come out in front. Again, that's one of the rules we wrote down in our foldable.
Teacher, please pardon this interruption.
So to finish this problem, I need to solve for x. To solve for x, I need to get rid of the log. I need to get rid of 5. But those are not two separate things. Those are stuck together. The log 5 is a representation of a decimal number. It's one thing, and so I cancel it out altogether. Log of 5, log of 5. Divide both sides, cancel it out. I will not get the right answer if I do not close the automatic parentheses. And so you are going to put that in your calculator. Log of 62, close parentheses, log of 5, close parentheses. And so this is 2.5643. Again, isn't that fairly easy? As you know, we usually work up in difficulty, so it does get slightly more difficult. The next problem that I want to look at is problem number 13. Problem number 13 doesn't have a log in it. 4, 9 minus 3x equals 97. When we were doing these kind of problems before, we were putting them to the same base. Can the 97 be changed to a base 2 or a base 4? No. So I have another technique now to solve this. I am going to take the log of both sides. Again, to be mathematically correct, the log word comes in front of the number. The power rule says all of this power, the 9 minus 3x, comes out in front. Log of 4 equals log of 97. I'm solving for x. The first thing I'm going to do is divide both sides by the log of 4. It's not two separate things. It all has to stay together. When I put that in my calculator, I need to do log of 97, close parentheses, divided by log of 4. Have I said close parentheses enough times that you got it? 9 minus 3x equals 3.3000. You do put those zeros down to show that it is rounded to that number, not exactly that number. I'm going to continue solving. What am I going to do with the 9? Now, when I did my calculator, I didn't clear it out and retype 3.3000. I just put the subtract 9. That's a little bit more accurate, actually. I don't think it makes any difference on this problem, but some of them it does. To continue solving for x, what do I do next? Divide it by negative 3. And so x is equal to 1.9. Now, I would like to go back to the pink paper because I had a lot of people ask me about the pink paper. First of all, on problem 2b, there's a typo. On problem 2b, where it says log of 100, it should say log of 1,000. Yes, but we're going to go back and do those also. I think I'm not sure if I told you this in this class, that we were going to start with the odds and go back to the evens. But one of the odd problems that I have had a lot of question about is problem number 3. Now, previously, we have learned how to take a log and change it into exponential. This is the base. This is the power. And a lot of people get stuck right there. They know that 2 to the 5th power is 32. But they have forgotten that 2 to the negative 5 power is the reciprocal of 32. So this is how we solved it previously, but a lot of people are having trouble with that negative exponent thing. Just wanted to mention that we know a change of base formula now. We have another way to solve this one. We can solve this one by saying the log of the big number divided by the log of the base number. This is equal to that. Can you put this in your calculator? It's 2 ways to do the same problem, and so you will get the same answer. But this helps out those of you that weren't very good at figuring out how to change it into the same base. Now, we cannot use this technique right here on problem number 5 because you have to know the base number in order to use the change of base formula. In problem number 5 on the pink paper, do you know the base number? No. So you couldn't use this procedure. On problem number 6, do you know the base number and the big number? So you could do a change of base on problem number 6.